When looking at the cerebral cortex, it has an interesting aspect that it works contralaterally. What that means is the hemispheres work on opposite sides of the body. So your right hemisphere is controlling the left side of your body. Left hemisphere is controlling the right side of your body. So it has this crossing over. And we mentioned where the decussation occurs. That was, remember, in the medulla. Now, that's not the only place. As the signals are sent down the spinal cord, sometimes that's where the crossing over occurs, is in the spinal cord. But regardless of where the information transfers over, it's still controlling the opposite side of the body. And the hemispheres aren't equal in functionality. They don't do the exact same thing. So that everything that happens on the right doesn't always happen on the left. That's because some aspects are more centered on the right or the left. There is some lateralization. So certain control features, certain aspects just have more functionality on one side versus the other side. But no matter what, nothing in the brain acts alone. Every area has another area supporting it, or leading information into it, or taking information from it. Your entire brain is one massive integrated computer, basically. It's constantly working together, constantly sharing information, sending information back and forth, up and down. It's constantly feeding information in and sending information out. It doesn't stop. The sensory areas. There's 4 primary sensory areas. And these 4 primary sensory areas are the primary somatosensory cortex, the primary visual cortex, the primary auditory cortex, and the olfactory cortex. Now, the primary somatosensory cortex, think of that as sensation coming in from your skin, your muscles. The primary visual cortex is vision, so primary visual. Then you have the primary auditory cortex. Auditory, what are you hearing? And then olfactory is what are you smelling? Let's go one by one through these. The primary somatosensory cortex is going to be found on the post-central gyrus. So this kind of area right there. So while the post-central gyrus is the structural location, the functional of that area is the primary somatosensory cortex. So for example, if there's a tag on that area saying, what is the structural name here? Structural is the post-central gyrus. What is the functional name of this area? Primary somatosensory cortex. Now, the primary somatosensory cortex, as I mentioned, receives all the information from your skin, from your muscles, from your joints. It's giving feedback about what's happening with the body around you. So looking at all your arms, your legs, skin on the torso, even your ears, your cheeks, your chin. It's all the feedback from all over your body. And it's interesting because it exhibits spatial discrimination. What that means is you can ID the body region based on what's being stimulated. Each spot on your body is wired into a particular place in your brain. So the whole entire body is represented spatially across that post-central gyrus, that primary somatosensory cortex. So the amount of cortex that's being given to a certain area is the amount of sensitivity. So think about it, from head to toe, what part or area of your body has the highest sensitivity? Well, if you're thinking hand or face, exactly. So you're looking at this kind of like a cartoonish drawing, but it matches the amount of cortex to the amount of innervation coming from that area. You can see how large and how much space the face takes up. You can see how much space the hand is taking up. But then the same amount of space that takes up the face is your trunk, head, neck, shoulder, and arm. All of that in the same space that was just your face. So it tells you that you have more sensitivity because there's more neurons bringing sensory information in from your face and hand than there is from your trunk or your leg. I mean, think about it. If you touch your upper arm and touch it again, they're too close together. You can't even feel two things. You feel one. but do the same on the palm of your hand, you can feel 2. So it's kind of an interesting test. Have your fingers just a little bit apart, and poking your arm kind of feels like 1, but it feels like 2 here. And if you're feeling 2 in your arm, put your fingers a little closer together. Get it so where you feel only 1. Once you feel that 1, touch the palm of your hand, you'll still feel 2. More nervous sensations are coming from your hand and your face than the rest of your body. So the idea of spatial discrimination. The primary visual cortex. Now that's back here, back here. It's at the posterior part of the occipital lobe. Now this is bringing visual information in from your retina, so from the eyes. It's bringing the information in and receiving it. It's not interpreting it. All it does is receive the stimulus from your eyes. So at this point, you still haven't figured out what you're seeing. You just know that there's something there, you're seeing it. That image is coming in, but then you've got to figure out what that is, and that's another step. So the primary visual cortex is just bringing that information in from the eyes, from the receptors in the eyes, from the retinas. The primary auditory cortex. Now the primary auditory cortex is on the lateral side in the temporal lobe. This primary auditory cortex, pitch, rhythm, loudness. So if you're singing, can you hit the right pitch? Or playing for that matter, an instrument. Rhythm, can you keep the beats steady? Can you have it change with the tempo? Looking at loudness, loud versus quiet. You can go back and forth and change those. That's all being interpreted by the primary auditory cortex. And then the olfactory cortex. Now, this area is the olfactory cortex. If you take the brain and split in half, you're looking at the inside of the brain. That's what we're seeing here, on an inside or a medial view looking out. The olfactory cortex is the awareness of odors when you smell something. Again, you can't necessarily know what you're smelling, but you know that there's a scent. That scent's being picked up, brought into this olfactory cortex, and then your brain's going to start the aspect of trying to process what it is. So all these primary areas is bringing sensation in. Primary visual, primary auditory, olfactory. It's bringing the information in and just starting the processing. Just starting trying to figure out, what are you seeing? What are you smelling? What is going on? So they're kind of just bringing it in and starting the process. We have to get into the association areas, which help you understand what information was brought in. So these are just bringing the information in. Then the motor area. We only have one. It's the primary motor cortex. The primary motor cortex, think frontal lobe. It's the precentral gyrus. That precentral gyrus is the location, the physical location of where this primary motor cortex is found. So you're looking for a location, a structure, precentral gyrus. If you're looking for the functional aspect of that area, that's the primary motor cortex. It's giving you conscious control of movements, from precise movements to skilled movements, and all your voluntary movements in between. Think about writing. You have to move your hand. Walking. If you're trying to balance on a balance beam. These are all movements that are helping out with your voluntary actions. So all these different voluntary, precise, controlled aspects are coming out of this. Now, the entire body, again, is represented spatially, just like it was on the primary somatosensory cortex. So that means we have everything mapped out along the entire primary motor cortex. The motor cortex equals the amount of control. So which areas in your body would have the highest amount of control? If you're thinking hand and face, as again, that's the answer. Think about the number of facial expressions you can make. Think about the number of movements and aspects of your hand. Now think about your leg. How much does that move? Forward, back, side to side? That's about it. So the areas that have more control, more innervation to them, hands and face, have more of the cortex themselves, just like we saw in the primary somatosensory cortex. So the primary motor cortex has the same spatial amounts. So the sensory areas, the motor area, some controlling aspects, as well as some sensory input aspects of your brain.